terribly, okay? And the reason why is because it's an equation that I have to transform, and the original equation is already transformed. Like, it's not just f of x, right? If you have y equals f of x and I ask you to reflect it in the x, and you put a negative in front of the f. If I ask you to reflect it in the y, you put a negative with the x. Done, correct? But that is not how I asked it. I gave you an original linear function, so that's a linear equation, right? And we have to transform it, which does make it more difficult. Okay? The best way to transform an already transformed equation, and transformed is, I say loosely, an equation that isn't just f of x, or just the parent function x, or x squared, or x cubed, which are easier to add to. It's used replacement notation. So, if it's a reflection in the x-axis, what does that affect? The y's, because in order to reflect on the x-axis, I need to negate my y's. Because if a negative y has to be positive, a positive y has to be negative, right? That's the only way I can get it. So I know that I need negative, it negates y's, just to help myself out. So I'm going to use replacement notation, and I'm going to negate the y. Okay? So I'm going to go negative y equals 1/2 x plus 3. You could have applied the negative in the front, but what you have to remember is it negates the entire equation. It negates, what did I put up there? Y's, plural. All the y values, yes? This 3 at the back is a y-intercept. It's also a y value. It has to affect it as well. So a lot of people will give me the equation y equals negative 1/2 x plus 3. That answer will be on the test. It will be wrong. I hope that you type it into your calculator at the very least to see that it's not reflecting where it's supposed to be. Okay? Because if you typed it in, you'll see it doesn't reflect on the y. I'm sorry, on the x. So you have to move that negative y over. How do we do that? We divide by -1, which divides every term by -1. So I get y equals negative 1/2 x minus 3. Which makes sense because I have a positive y-intercept of 3. If it reflects in the x-axis, that's going to become a negative y-intercept. Yes? If you did not distribute that through, which I would suspect is all of you, I haven't shown it to you yet, star it. Highlight it. Remind yourself. You got it right? Yay. Multiple choice options as well are nicer because you can type them in, correct? You could look to see which one actually reflected in the x-axis. Okay, a reflection in the y-axis negates the what? Negates the x's. So I'm going to get y equals 1/2 negative x plus 3, which I could stop there. Weird looking, but I could stop there. Or I could go, what's 1/2 times negative x? Because they're being multiplied because they're side by side. Negative 1/2 x plus 3. And it makes sense that that would stay the same, that plus 3, because plus 3 is the y-intercept. And the only thing that isn't going to change is the y-intercept, because it's on the y-axis, and the y-axis is where the points don't change. It's where your invariant points lie. It's where your x's are 0. Okay. Describe in order. The order of transformations is always SRT, SRT. You could get away with RST like the alphabet, and you wouldn't be wrong. The reason why is stretches and reflections multiply, transformations add and subtract. So in order of bed mass, you would have to go stretch reflect first because multiplication, and then translations. So if you went RST like the alphabet, you wouldn't be wrong because both of them are multiplication. They'll often list though SRT, so I just listed in that order too. But R and S can be interchangeable, it's multiplication. So if you forget, worst case scenario, list them in alphabetical order. Reflect, stretch, translate. Okay, so I need to have it in y equals. So I'm going to subtract the 5 over. Now, a lot of people are like, well, it doesn't have a plus 1 in front. It is true, but you could go negative x if you really want to. Does it change anything when it's just a negative x, though? No. If you don't make it have a positive 1 in front, it'll affect only your translations. So if you don't have a translation, can it affect it? No. So that's why you don't have to really worry about the positive 1 in front if there's no horizontal translation. Okay? So we still have to go stretch, reflect, translate. There's no stretches because we're learning that today. So we have a reflection. It's with the x, so it's a reflection in the y-axis. And is that 5 with the x or outside of it? It's outside, so it's a vertical translation. And y's are always awesome. X's be crazy. Vertical translation, 5 units down. And then we have to give mapping. Mapping and words are the same because they're in the heart, remember? That was actually a pretty good heart. My hearts usually suck. XY becomes negative x. If it's with the x here, it's going to be with the x in mapping, yeah? And then y minus 5. Do you see how easy it is to put the negative with the wrong one? Do you think they'll have it there on the test as a multiple choice option? Sadly, they will. B is in y equals, but we don't have that negative. We don't have a positive 1 in front, correct? So I have to do that first. I'm going to get y equals negative f. Take out a negative 1. Negative x divided by negative 1. Remember, when you GCF out a number, you're actually dividing. Because in order to put that negative 1 back in, I need multiplying, right? So if I'm taking it out, it has to be the opposite of multiplying, which is dividing. So always use that. If you forget, be like, okay, well, how would I put it back in? Oh, I've multiplied, so obviously I divided. So negative x divided by negative 1 is x, and positive 3 divided by negative 1 is negative 3, so it's actually 3 right, not 3 left. If you forget to take it out, 3 right will be, or 3 left will be an option on the test. So if you forget to check for that positive 1 in front, your answer will be there every single time. It won't be correct. Okay? The moment I had to make you take something out of that x to make it a positive 1, it's the standard of x, just so you know. That's that top 25. So, let's talk about reflections first. The only ones you can actually put together is reflections. So because it's negative on both, I can say a reflection in the x and y axis. It's the only one you can put together. Okay? And then we have a horizontal or vertical, doesn't matter which one, but translations come next. Horizontal translation, 3 units right. Because we're crossing the arrow. We're going from equation to words, right? That is a G. Ooh, scary. When you cross the arrow, it switches. So if it's x minus 3, it's actually a horizontal translation, 3 units right. And y's are awesome. They're always the same. So a vertical translation, 2 units down. And then our words and mapping are the same. So I want to reflect in the x and y axis. So I'm going to have a negative x, comma, negative y. I have to do 3 right, so I'm going to add 3. I have to go 2 down, so I'm going to subtract 2. Can you guys open the door so there's some air flow? It's rough and warm in here right now. I mean, this is literally 24 in here. How's that? There's obviously a heater running for no reason. Okay. We're moving a point. When we move a point, what do we use? Mapping every single time. When we move a whole bunch of points in graph, we use mapping, okay? So it says determine the coordinate of the image point under the transformation. So we have to have it in y equals and a 1 in front of our x. Y equals 1 in front of my x, correct? I'm going to use mapping. So I'm going to go x, y becomes anything in the bracket with the x affects the x. All I have is x minus 5. So that's 5 to the right. So I'm going to go x plus 5. Mapping and equation are always opposite. Yes? And then I need to go 4 down, so I'm going to go y minus 4. And then I apply my coordinate. 110 becomes 1 plus 5, comma 10 minus 4, which becomes 6 and 6. B is in y equals already. So I can go straight to mapping. X, y becomes anything in this bracket affects the x Anything not in that bracket does not affect the x, right? So I have a negative not in that bracket. So I'm going to get a negative y. Yeah? And in this bracket, I have x plus 12. So in this bracket, I'm going to have x minus 12. Because equation and mapping go across the arrow, right? So they switch. Yes? I'm telling you this diagram. I know it's stupid, but it will help you. If you get stuck, go to the diagram. Okay? And then we have 110. It becomes 1 minus 12, comma, negative 10. It becomes negative 11, negative 10. And then C, what's my problem? There's a negative in front of the x instead of a positive one. So I have to go f, negative 1, x minus 3. So my mapping is going to be x, y becomes, and all of this is with the x, correct? You see that? Oh, y. Nothing's going to happen to my y. There's nothing outside of that bracket. Yeah? And I'm going to get negative x plus 3. Mapping doesn't get brackets in it. Just write what it is. So it's negative x, positive 3. Don't overthink it. Because you want to negate your x's, and then you want to add 3 to all of them. Right? That's what you want to do, because you want to do multiplication, then addition, subtraction. All right. So we have 110, which is going to become negative 1 plus 3, comma 10. So 210. Number 4, I'm moving a graph, which means I'm moving numerous coordinates. When I move numerous coordinates, what do I use? Mapping. So I'm going to get y equals g of negative x plus 1. So this affects my x. That does not. I'm going to get x, y becomes negative x, y plus 1. So unless it's in this bracket, it doesn't affect the x. Yes? So equation to mapping is actually easier. If it's in that x, it affects the x. If it's not, it affects the y. So we have negative 6, 3. We have negative 4, negative 3. We have 0, 0. And we have 4, negative 4. I'm going to use mapping for all of them. And the reason why you want to show the mapping is if this is a written response, sometimes people just get one coordinate wrong, like they just map it wrong, correct? But if you show all your work, can I give you way more marks? Yeah. If you just draw a wrong graph, you're going to get way less marks. Okay? All right. So we're going to get negative and negative 6, comma 3 plus 1. So we get 6 and 4. Plot that. It's reflecting on the y, so it makes sense that it's on this side right now, that coordinate. Then we get negative and negative 4, negative 3 plus 1, which becomes 4 and negative 2. Then connect it. Then we have 0, 0. It's going to become negative 0, comma 0 plus 1, which becomes 0, 1. Connect it. And then we have negative 4, comma negative 4 plus 1, which becomes negative 4, negative 3. Now, a lot of people will say to me, oh, yay, this is invariant. It didn't change. That true statement? It was this one. It's now this one. It did a flipperooski, and yeah, it moved. So she ain't invariant. So just because the point still exists does not mean it is invariant. Invariant means did not change. Correct? If you look, are there any invariants? No. All right, can you guys go to your notes? We're going to go to the stretches part of it. Stretches. So stretches stretch the graph. It's crazy. I know, like remarkable. It's weird. You stretch it wider or narrower, taller or shorter. Wider or narrow would be a horizontal stretch, correct? Taller and shorter would probably be a vertical stretch. Vertical stretch. Oh my gosh. Now, think about this. If we stretch narrower, the graph may actually look like it's vertically stretching, correct? Because if we stretch narrower, it might look taller. Yes? So you do have to watch what you're doing. And in some instances, a vertical stretch could replace a horizontal stretch. So they can work vice versa. So when you're like, it looks like it could be this, you're right. Because it could be one or the other. When it's a parabola, things like that. So stretch is a transformation that changes the size and shape of the graph. The original and the new graph are not congruent. Congruent means the same. There are two types of stretches, vertical and horizontal. We talked about vertical last year. Horizontal is coming into play this year. It's with the x's be crazy. So get ready. When we go from equation to words and mapping, that number is going to switch in some way because x's be crazy. All right. So vertical stretches. If I give it to you in this form, grab a pen, change the page for instance. All right. So if I give it to you in this form, that's a vertical stretch. This is still a vertical stretch, but I would have to multiply by that a and put it in front, and then it would look the exact same, correct? They're the exact same. One of them's just not in the format I like. I like having it in y equals and not thinking. If I left it on the y, it would have to flip and be crazy like the x's. And then you're having to think, do I keep, do I change? You always get it into y equals, you just keep your y's the same. Life is way easier, okay? So we say a is a vertical stretch by a factor of a about the x-axis. This is going to be your wording. You don't get a choice. Remember how I said you don't get to, like, you know, make it a little more fantastic for yourself? You don't. So it's a vertical stretch by a factor of a about the x-axis. I did learn you don't put vertical and horizontal, but the moment you drop off vertical and horizontal, you guys put it with the wrong axis. So I'm pushing that you have to put vertical. So vertical affects y's, and they'll be about the x-axis, right? It's always about the opposite axis. It reflects in the x-axis when it affects the y's. Vertical stretch is about the x-axis. Cool thing is it doesn't change. It's the same thing. Because it will be about the x-axis if you're stretching it too, right? Because you're going to pull it this way or this way, squishy. Okay? Your mapping notation is x, a, y. So you multiply it, just like you multiplied reflections. Verticals are awesome. Whatever it is, it is. If it's an A, you put an A. If it's a 3, you put a 3. If it's a 5, you put a 5. Yeah? The points on the x-axis are invariant. This is important. The points on the x-axis, if all I'm doing is vertically stretching it, if that's all I'm doing and I'm not, like, translating it, because translating it would move it off, correct? But if all I'm doing is vertically stretching it, the x-axis is where they're invariant because I'm multiplying my y's, and my y's on the x-axis are 0. Multiply anything by 0, you get 0, right? So they're not going to change. So for example, if I use x0, which is any x-intercept, and I apply that a to the 0, I'm still going to have x0. So it's going to stay. If a is a negative sign in front of it, that's not a stretch. Remember, that's a reflection. You just learned that. Okay? You don't say stretched by a factor of negative a. You say stretched by a factor of a about the x-axis, and then it's a reflection in the x-axis. It's two things if it's negative. Your stretches are never negative, because negative is not a stretch, it's a reflection. So if you saw a negative stretch on your diploma, you could cross it out, because you can't have that. That's a stretch and a reflection. So, describe the transformations that occurred into the original graph of y equals negative 4 f of x. Sorry, if the original graph of y equals negative 4 f of x was, you will learn to have a party in your head when you see that the original is y equals f of x. Because that is the easiest way they can ask you. Hey, nothing happened. Hey, something happened. State what the something is, right? Hey, I gave you an equation with some transformations. Hey, I'm moving it again. How did it go from here to here? That's way harder, right? Way more difficult. So y equals f of x is the best thing they can give you. So you get that, you're just like, yeah, thank you. All right. So, and then we're going to state mapping. So we go stretch, reflect, translate. Is there anything with the x? No. So all we have is a vertical stretch and a reflection in the x. It's not with the x. Nothing happens to the x. There's nothing about y. Okay. So we have vertical stretch. Am I allowed to short form anything? No, never, ever, 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 ever. So you can't go VS. Well, you can if you don't want full marks. It's options. I wouldn't if you want full marks. Vertical stretch by a factor of, what's the number in front? 4. About the what axis? X-axis. Because it affects the Y's. Notice how I did not put -4, correct? What does that negative do? Reflection in the, which axis? X-axis, because it affects the Y's. It's always about the opposite axis of what it is affecting. Because if Y's are being affected, let's just, remember we want to know the Y. We always want to know the Y. We don't want to know the memorize. The memorize and stress don't work well. Stuff just falls out of your head. Why is it about the X-axis? Well, if my number's up here, it's going to be down here for reflection. So that's the X-axis, right, when I affect my Y's. If it's 4, it's now going to be, let's say, 8 if I times it by 2. In this case, it's a 4 factor. So 4, it's going to be 16, let's say. That's still about the X-axis, right? It's not doing anything with the Y. So when it affects Y's, it's about the X-axis because it's affecting itself around that X-axis. Okay? And nothing's happening to my X. My mapping, I can either go from the equation or I can go from words. It doesn't matter. Because it's a Y, nothing changes. So I'm going to get X, and then my Y is going to be, what's up there? What is this? -4. What's this going to be? -4. Y's are the best. They don't change. What it is, it is. Right? Y's are amazing. Yeah.
I'm confused about this stretch factor again, because isn't this X, like the X-axis is horizontal and the Y-axis?
Yeah.
When you stretch it, you move along the, if you're making a vertical stretch, then you're making it along the Y-axis.
It's along, I didn't say along, I said about. So it's about which axis. So if I started like here, and I didn't have -4, let's just say I had 4. Let's say my coordinate was 4, 1. It's now going to be 4, 4, right? Which axis did that stretch on? Not this one. It got taller from the x-axis. You know what I'm saying?
Yeah.
If it was down here, it would be here now.
Okay.
So that's still about the x-axis.
Okay.
It's not doing anything pertaining to the y.
Okay.
Yeah? All right. Good question. Do this one. Go. Try domain and range. It's going to be a blast. There's interval notation and set notation. You need to know both. Because they can ask you. You don't get a choice. So, in this curriculum, for me to prepare you for any type of question you could be given, okay? We have to be able to state the transformations. We have to be able to do mapping. We have to be able to state the equation. I have to be able to give you any form of those to any function in the world, and you have to be able to do the three, backwards and forwards in your sleep, without screwing up the signs, and without flipping when you should flip or not flipping when you shouldn't. Yes? Other things is that I should be able to give you any function in the world, no matter what domain and range it is. It might just be this function's domain and range is this, and I will give you a graph. The domain and range they give you might only have variables. It might be x is greater than k and y is less than n, k and m are whole numbers. Okay? It could be stuff like that. It could be, I mean, it does happen. Okay? They give you questions that do not have numbers. It's only variables. But you will be able to do it. We prepare you for that. Okay? Okay. So, that is what I need to give you guys in order for you to be successful. Yes? All right. So we start off with easier ones where it's a graph. So I need to do my mapping and moving coordinates. Nothing happened to my x. My x is staying that way. This is a y. It's not with my x. Y's are awesome. They just stay the same. So every one of my y's is being doubled. So here I have -2, 0. It's going to become -2 and 0. Because it's on the x-axis, and I stretch about the x-axis, and whatever I stretch about, those points are invariant. Now, if I added a vertical translation, it would take them right off of there, and it would throw that whole invariant thing right out the window. Yes? So it only works when you just have stretches or just have reflections. The moment you get vertical or horizontal translations, it's going to shove that graph around and mess with your invariant points. Yes? But stretches and reflections give a lot of invariance because wherever you're only multiplying with those. So wherever y or wherever x, y's and x's are zeros, depending which stretch reflection you have, they're going to stay. Because when you multiply by 0, it stays 0. Okay? Then I have negative 1, 2. It's going to become negative 1, 2 times 2, which is negative 1, 4. And then I have 0, 5, which becomes 0, 2 times 5, which is 0, 10. That didn't remain invariant because it's about the x-axis, not the y-axis, right? Okay, we want the domain and range of the changed one. Okay? There's set notation and interval notation. Set notation uses the squiggly brackets because the squiggly brackets mean the set of. That's literally what they mean. They mean the set of, aka set notation. The set of. Every single bracket, line, upside down letter, once you get into some more advanced mathematics, if you do, all mean things in math. The symbol means something. So this means the set of if and only if you close the bracket. So if I have an open squiggly, I have to have a close. They call them curly. I don't know why I like calling them squiggly, but I do. The curly brackets, open and closed one mean the set of. Okay? Now is domain x or y? X. Now I'm going to go up here and I'm going to look. This is y and x, so we're good. We can use x and y. They could use m equals f of t. Then I would have to use t's and m's. Whatever the equation is, I have to use. These are x and y, so skip. Domain x such that. The reason why you do a straight up and down line is it means such that in mathematics. So fun. I know. Frenchies, it's going to be different. I believe in you. I think it's easier. Okay. So, our x values are between what and what? What's our lowest x? Negative 2. Shh, table. And our highest x is? Positive 4. So we always go low to high. Negative 2, 4. I plop an x in the middle. And then I have to do inequality signs. You have to read from the x. So you're reading from the x. So guess what? They're both, I call them loser-losers to remember it. But really, they both look like less than or equal to signs as long as you go from the low to the high, because you are reading from the x. So it's open to the x. Do you see this? So it's x is greater than or equal to negative 2. X is less than or equal to 4. Do you see how we're reading from the x? You don't read left to right. You read from the x. X is greater than or equal to negative 2. X is less than or equal to 4. So these are both not actually less than or equal to signs. This is a greater than. That's a less than. Because you read from the variable. Do we agree? If that falls out of your head, go low to high, L's. L's, 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 L's. Low to high, L's, L's. I would prefer you understand why, but if that falls out, revert back to L's. Okay? It's equal to because these are closed dots. Yes? And then we follow behind with a comma, XER. Does anyone know why we do this, or you just do it because you're told? But why? Why do we have to state that? What's real number? But why? Because every single coordinate between negative 2 and 4 can be found on this graph. So do you see how these coordinates are connected? I start with my line, I draw the line, I keep going, I draw until I hit this closed dot. That's why. So what you do is you state the most important part. Negative 2 to 4 is where I'm going to find my x's. And then I have to follow behind with what those x's can be. If x could be only integers, guys, I would just have coordinates. I would have a coordinate at negative 2, and I'd have a coordinate at negative 1, I'd have a coordinate 0, 1, 2, 3, 4, and they would not be connected. So if this here was an I, which weirdly enough in universities can be a Z, but for Greek talk it's an I for integers, which is weird Z. for integers once you get to university. But there's an I, then I wouldn't be able to connect them, correct? Because I physically start at -2 and I draw, ooh, that was bad. And I draw, and I draw, and I draw, and I never lift my pencil. It's real numbers, because real numbers are every decimal that exists in the world. Sans, negative, burdens. So that's why it's reals. Yes? Does that make sense? So if you never pick your pen up in between those values, you XCR every single time. Now, interval notation is often easier. There are some times where it sucks. So don't always be like, I wish it was always interval. So we're going from -2 to 4. You always list them in the order that they are, low to high. And then there's equal to signs on here, correct? If it's equal to, you're going to square bracket towards it. You guys think you open brackets out or something like that. Yeah, just square brackets in. If that falls out of your head, they'll realize that you're a French English kid and they'll stick with you. Because they're not that. Because it would fit another format, right? And they'll figure it out. Because we've done it before. We're like, ooh, this page took French until now. Because their brackets are the wrong. Okay, range. What's my lowest Y? 0. What's my highest Y? 10. Same thing. So we're going to go Y such that, the set of Y values such that 0, 10, a Y value less than or equal to, less than or equal to, and then do I connect? Is my pen running the whole way through? So it's Y's known as reals. And then 0 to 10, because those are closed dots on both ends. Yeah? Now a lot of people will fall to 0 and 10. If they're open dots, 0 and 10 would have round brackets, correct? And those round brackets would make that look like a what? A coordinate rather than a domain and range. So you have to watch yourselves. If it is a not equal to, it looks a heck of a lot like a coordinate. And then people will say, well, how can I tell? They'll say the domain is this. The domain of the function is this. And it has round brackets. That's a domain. That's not a coordinate anymore. Right? So you have to watch yourself. So they'll specify what it is. Yeah? Okay. Next page. This domain range isn't too bad. We're going to go to horizontal. So horizontal, just like all the x's, be crazy and make your life a little more complicated. Okay? So if I had x plus 3, I went 3 to the right. If I had x plus 3, I went 3 to the left. If I had x minus 3, I went 3 to the right. Correct? Stretches are very similar in that they're crazy as well. So horizontal stretch, this is here. It's a b. Do you see that? It is a horizontal stretch by a factor of 1 over b about the y-axis. It reciprocates. It flips. It be crazy. Okay? So the only thing on an x that stays the same is a reflection, because you can't really flip a negative. It would be positive and that would be stupid. So the reflections all say negatives, but from an equation to words and mapping, your x's switch horizontally and in transformations, and they also flip as a stretch. They reciprocate. So my mapping notation is going to be x, sorry, that's a lie. It's going to be 1 over b x y. Remember, because from equation to words and mapping, x's be crazy, they flip. Yes? X's be crazy. So your invariant points are on the y-axis this time, because that's where your x's are 0. And if I multiply them by 1 over anything, say 0. And the b having a negative sign, remember that's a reflection in the y. Okay, let's talk about this one. Transformations and then mapping. So this is in front of the x, the horizontal stretch. I am going from equation to words. I'm going over that arrow. Equation to words. Equation to the heart. Correct? So what happens to my x's? They flip. And in this case, they legitimately flip. Okay? So this 5 is going to become what in mapping and words? The 5 is going to become 1 over 5 in both words and mapping, because we go words and mapping in the same heart. Equation, correct? We're going from a, why do I want to keep writing examples? I don't know what's going on. E, Q. Equation. So we're going from equation to words and mapping, correct? So only our x's be crazy, our x's flip. Equation to words and mapping. So it's going to be 1/5 in words and it's going to be 1/5 in mapping because once I flip it, these two are the same. Yeah? Yeah? See how this little diagram's a little bit helpful? Because it is confusing. So we're going to have a horizontal stretch. By a factor of 1/5. About the y-axis, because it's always about the opposite. And because I used 1/5 in words, I'm going to use 1/5 in mapping, because they're in a heart. Whatever I use in one, I use in the other. Yeah? True? Very important. So we lock that in. Okay? So I used 1/5 in words. I use 1/5 in mapping. Same thing. So I'm going to go x, y, and it's with my x, so it's going to be 1/5 x, comma, y. Yeah? Try example 2. What's the 2 going to become? 1/2. So this graph's actually narrowing. Yes? Not widening. Narrowing. It's halving. Go. So we're going to go half of -2, comma 0 becomes -1, 0, which is halving. Makes sense. Shrinking. -1, 2 is going to be a half of -1, comma 2, which becomes -1/2 and 2, or 0.5 and 2. It's also shrinking. The y-axis is going to remain invariant because I'm going to do a half times 0 and 5, which is 0.5. And then 4 0 is a half of 4 on the 0, which is 2 zeros. Like that. So it's going to be from -1 to 2, correct, my domain? So it's going to be x such that -1 is less than or equal to x is less than or equal to 2. X and L are the reals. In set notation and integral notation, it's -1 to 2. Pardon? And then our range is from 0 to 5. Did our range change? No, so that could be a question on the test too. Which of the following makes my range not change? You have to watch too. Sometimes it's which one doesn't change. Or what is the range and it says the range does not change and you're like suspicious. Sometimes it doesn't. Sometimes that's the question. So it's y such that 0 is less than or equal to y is less than or equal to 5. Okay, then flip. All right. So when we look at this one, example 4, it says describe the transformations that occurred if the original function is y equals 4 minus x cubed. So is our original function f of x? No, it's something else. It's this. So this was there. Whatever happens to that is the transformations, right? So this is still the same. See that? So the only thing that's different is this 3 in front. And what is that? Vertical stretch. And verticals are awesome because they're y's and y's don't change. So that's a 3. In mapping, it's a 3. In descriptions, it's a 3. It's a 3 for life. Y's never switch. So it's a vertical stretch. By a factor of 3 about the x-axis. So we have x, y, becomes x comma 3y. Okay. Whenever you have a squared x or a cubic x or x to the 4 or something like that, right? It has to be in brackets squared or in brackets cubed or in brackets 4 to affect the x. Yes? It has to be with it. So, my 4 is the same, my 4 is the same. That didn't change. And then I have x cubed, and now I have 2x cubed. So is that with the x or not with the x? It's with the x. Is that an equation or words or mapping that we're looking at? It's the equation, correct? We're going from equation to words. We're going over the arrow. So that 2 is not going to stay a 2. What's it going to become? A half. So it's a horizontal stretch. By a factor of 1/2. About the y-axis. Now if I go from words to mapping, they're in a heart. That number stays the same, right? So in words I'm using a half. So in mapping I'm going to use a half. They're in words and mapping, they're in a heart. But for words I use a half, mapping I use a half. Okay? So it's going to be xy becomes 1/2 x comma y. I could have went from equation to mapping. If equation is a 2, mapping would be a half, right? They flip, they're over that arrow, that double-headed arrow. Yeah? Okay. I want you to look at B for a second. We're going to do all of these, but B is a tricky one. Because this one, people will say there's not a 1 in front of my x. Remember, it's like this, x squared. We agree? So this is x squared. So is there a 1 in front of my x? Yeah. If it was -2 in brackets squared, that would be with the x. But is it? No. So this is vertical, the -2, and this is vertical, that +3. Nothing is happening to the x on this one. What's the problem with the second one? The x doesn't have a what? A positive 1 in front of it. It has a -2. You agree? So I have to do something before I talk about it. So it's still going to stay with my x. I'm going to get -2x. -2x divided by -2 is 1x, so that's good. 4 divided by -2 is -2. Now I can do my transformations. Yeah? And then this one just affects my x, and that's a vertical. So you have to do transformations and mapping for that, and then transformations and mapping for this one. Watch this one. It's a -1 in front. That's a hint to you. Yeah? So I want transformations and mapping for 5 and 6.